Following video is part 4, the exponential differential equations. So here again in our series we have initial value of y0 equals y sub 0. So when x is 0, the initial value of y is y sub 0. The differential equation in this case is y prime equals k times y. And so the rate of change is a percent of itself. The rate of change is a percent of y. So the function's an exponential function. Y equals y sub 0 times e to the kx power. The little hat there indicates to the exponential, the exponent, superscript. The initial values that we're going to put into the model are k equals 0.25 and y sub 0 equals 50. So what we're doing here is showing two models. Again, this is a level and a flow model. So each one of these represents, or symbolically represents the equation. And we can see a graph of each of these equations. The difference between these two models, the top one, the flow is going out of y, and in the bottom one, the flow is going into y. So what we want to do is predict what we think take a moment to predict what you think the graph is going to look like with an exponential differential equation. So one of these, well, we've got two graphs, and we're going to show you these. I'll make these bigger. So here is the graph of y and flow. So the flow is, remember, k times y is y prime equals k times y. So the flow is this blue line here. And this is y. So that's when the flow is going out of, so there's an exponential decay. This is the y2, which was the lower model where the flow is going into the level. So it's a constant, it's increasing at a percentage of itself. So you see y is going up exponentially. The flow here is k times y. It's y prime is the flow differential. And it's not going up as fast, but the stock is. So what we have here is an extension of just basic math to show you how a stock and flow modeling can be used with equations to create a simpler algebraic expression. So we just use the differential here in the flow. That's the equation that's in the flow, is y prime equals k times y. It's just an simple algebraic expression. We don't have to program e equals k to the x. We do the differential, and then the computer takes care of the integration of y. That's what the level is. It's the accumulation, the integration of the differential equation that's in the flow for both of these. And that completes part 4 of our differential equations.